Hi, I'm Josh from Georgia College. In this video I'll be discussing a few different exceptions in Java and the proper way to handle each one. So here's the problem. Let's say you want to create a program to open a file and read an integer off of it. In theory, this is a pretty simple program, but there's a lot that can go wrong. What if your program can't find the file? What if there's an error when trying to read from the file? What if the information from the file can't be stored as an integer? If not handled correctly, these issues could potentially crash your program. This frustration can be avoided, however, if you tell your program how to handle these problems ahead of time. This is known as exception handling. So what is an exception? An exception is an object that is generated as the result of an error or an unexpected event. To prevent exceptions from crashing your program, you must write code that detects and handles exceptions. Some examples of exceptions include trying to access an array index that doesn't exist, or trying to open a file that can't be found. This slide contains some basic terminology that's used when referring to exceptions and exception handling. When an exception is generated, it is said to have been thrown. An exception handler is a section of code that gracefully responds to exceptions when they are thrown. If your code does not handle an exception when it is thrown, the default exception handler will deal with it, printing an error message, then crashing the program. As I said earlier, there are a number of different possible exceptions. These exceptions come together to form a hierarchy. Two examples of superclass exception classes that form the top of the hierarchy are IOException and runtime exception. IOException contains subclasses for instances when you try to read past the end of a file, or when you try to open a file that doesn't exist. Runtime exception contains subclasses for exceptions that result from programming errors, such as accessing past an array's boundaries. To handle an exception, use a try statement followed by a try block. Inside of the try block will be one or more statements that are executed and that could potentially throw an exception. After the try block, a catch clause appears. The catch clause will include a parameter that will contain the exception you're trying to prevent. Inside of the catch block, you will place the statements that will be executed if such an exception is thrown. The benefit of this is that even if the exception is thrown, the rest of the programming following the catch block will still execute. Sometimes the code in your try block may potentially throw more than one exception. If this is the case, you can simply add more catch blocks for each exception. This will be shown in the code example to follow. In this example, I've created a program that attempts to do the things discussed at the beginning of the video. I attempt to open a text file called myFile. I then attempt to read from the file and store the data as an integer. To start off, I'm going to refresh your memory by showing you what happens when an exception goes unhandled. Here, you can see that I have a text file already created. However, it does not share the same name as the one I'm trying to open. When I run the program crashes and I get the default error message created by the default exception handler. Next, I'm going to remove the comment markers from around the first catch block, and then I'm going to run the program again, this time allowing my program's own exception handler to pick up on the exception. As you can see, this time it prints off the message underneath the file not found exception in our catch block and prints off the message at the end of the program. I've gone ahead and changed the name of the text file to match the name of the file I'm trying to open. However, now another potential problem exists. The data in the file is a character and therefore cannot be stored as an integer. To avoid an unexpected crash, we'll need a catch block to handle this kind of problem. Here, you can see we have a catch block just for the occasion. If for some reason the data in the file is not an integer, then this block will catch the exception and print off a message letting us know what happened. For this final run of the program, I've changed the data in the file to an integer. Now, barring any special circumstances, the program should run without throwing any exceptions. Even though exception handling may not seem as useful in an instance where the program runs properly, its importance in debugging and recovery should not be overlooked. Well, that about wraps up the discussion of exception handling. While I tried to be as thorough as possible, there are still a few finer points that I wasn't able to cover in the video. As always, feel free to leave any questions you have in the comments section below, and be sure to subscribe if you'd like to be notified when a new video is posted. Thanks for watching.